So 2.6 goes over shifts with graphs. A lot of these graphs that you're going to be looking at are different types of functions. Ones that I focus on specifically when you're looking at your transformations is this quadratic function. Like you see here, this y is equal to negative a times a negative number times x minus h squared plus k. If you have a negative that comes in front of those parentheses, then that means that you have a reflection over the x-axis. If you have a number, whether it be a fraction or a whole number that's in front of the parentheses, it's a vertical stretch or compression. It is what you see. Now, if you go inside the parentheses, you want to think opposite of what you see. So that reflection across the y-axis would be a negative in front of the coefficient of x. The number in front of x, so that coefficient of x would represent a horizontal shift or compression, or a horizontal stretch or compression. If you're dealing with that stretch, it's going to be a number less than 1. If you're dealing with the compression horizontally, it's going to be a number greater than 1. The h that's inside the parentheses is your horizontal shift left or right. Again, that's opposite of what you would think. So normally, it's a minus number, which means you would be going to the right. If it's a plus number, then you'd be going to the left. So then the last thing that you have is that vertical shift up or down. So if it's plus a number on the outside of the parentheses after the parentheses, it's going to be going up that many units. If it's minus a number, it's going to be going down that many units. So if we look at some examples, for example 1, we're not going to be graphing these. We're just going to be identifying the transformations. We have for a, g of x is equal to x squared plus 3. This plus 3 is not inside the parentheses, so it is what you see. That plus 3 means that we're going up 3 units. So we just identify that this plus 3 means that we're going up 3 units. On example B, we have h of x is equal to x squared minus 2. This minus 2, again, outside of parentheses, no parentheses visible, so we're going to be going down 2 units. The next part of these transformations is that horizontal shift, so left or right. If it's inside the parentheses and it's plus a number, you're going to be going to the left so many units. If it's a minus a number, you're going to be going to the right those many units. So if we look at the example A here, we have g of x is equal to parentheses x plus 4 close parentheses squared. That's plus 4 is inside the parentheses, so we're going to think opposite. What's the opposite of a positive 4? A negative 4. Negatives on the number line go to the left, so this is going left 4 units. For example B, we have h of x is equal to x minus 2 squared. That minus 2 is inside the parentheses, so think opposite. The opposite of minus 2 is plus 2. Positive numbers are on the right of the number line, so this is going to the right 2 units. Next, we're going to be looking at reflections. If that negative is in front of the parentheses, then we are reflecting across the x-axis. If that negative is inside the parentheses in front of x, then we're reflecting across the y-axis. So if we look at example A here, we have f of x is equal to a negative x squared. There's no parentheses happening here. There's no symbols between that negative and that x squared. So this is a reflection across the x-axis. For example B, we have g of x is equal to the square root of negative x. That negative is underneath the radical. It would be treated as if it's inside the parentheses as well. So this one is a reflection across the y-axis. you want to think about these transformations from left to right. So if it's inside the parentheses, you're going left or right. These transformations are also going up or down, and that would be if it's outside of the parentheses. So anything that's inside is going left to right. So if you see this negative, like in example B, it's underneath that radical, it's treated as if it's inside the parentheses, you would be moving from left to right. So what axis are you crossing over? If you're moving from left to right, the only axis that you can cross over is that y-axis, which is why we have a reflection across the y-axis when that negative is underneath that radical or inside the parentheses. Next, we're going to look at vertical stretches and shrinking or stretches and compressions. If you have something that is in front of the parentheses, then you have a vertical stretch or compression. If that number is greater than 0, then if it's greater than 1, you have a vertical stretch. If it's less than 1 but greater than 0, then you have a vertical compression. So we look at example A here. We have g of x is equal to 3 times x squared. That 3 is not inside parentheses, so we know whatever's happening to it is vertical. Now, do we have a stretch or a compression? No parentheses, it is like what you see. 3 is greater than 1, so it's getting bigger. So this is a vertical stretch by a factor of 3. For example, B, you have h of x is equal to 1/3 x squared. That 1/3, again, no parentheses visible here. So that 1/3 means that we're doing something vertical. And because it's less than 1, we have a vertical compression by a factor of 1/3. Next, we're going to be looking at horizontal stretches and compressions. These will be inside parentheses or underneath the radical and will be the opposite of what you normally would think. If the number is less than 1, then you are going to be horizontally shrinking. So that's going to be a compression. If it's greater than 1, then it's a stretch. However, you want to keep in mind, you're thinking opposite. So if that number in front of x in front of the parentheses, inside the parentheses, if it is a whole number, you're going to take the reciprocal of that number, and the reciprocal of that number will tell you if it's a stretch or a compression. If you take the reciprocal of the number and it is less than 1, you have a compression. If you take the reciprocal of the number and it's greater than 1, you have a stretch, and this is happening horizontally. So if we look at examples, for A, we have y is equal to f of 2 of x. So the 2 is in front of the x inside the parentheses. So we take the reciprocal of that 2, which is 1/2, and that represents a horizontal compression by a factor of 1/2. For B, we have y is equal to f of 1/2 x. So take the reciprocal of that 1/2, that's 2. That gives us a horizontal stretch by a factor of 2. So these factors that we're getting are the reciprocal of the number that's the coefficient of x inside those parentheses for these horizontal stretches or compressions. So again, if you take the reciprocal of the number in front of x inside the parentheses and it's less than 1, you have a horizontal compression by that factor. If you take the reciprocal of the coefficient of x inside the parentheses and it's greater than 1, you have a horizontal stretch by that factor. The last part of your notes for lesson 2.6 deals with even and odd functions. Even and odd functions, you are going to use a number greater than 1 and use a negative with it. You're going to plug it into that expression and simplify. If you plug that number in, so let's say you use -2. If you plug in -2 for x and you get a positive, then you have an even function. If you plug in a -2 for x and you get a negative, that means you have an odd function. For even and odd functions, we are going to plug in a negative number and a positive number, so opposites of each other, and see what we get for our solutions. If we plug in, let's say, a -2 and a +2, and we get the same exact number, then we have an even function. If we get opposites of each other, we have odd functions, and if we get two totally different numbers, then we have neither of these functions. So we look at example A, we have f of x is equal to x to the 5th power plus x. So if we're going to plug in a -2 and a +2 here, so A is f of x is equal to x to the 5th power plus x. So we plug in a -2 and a +2. We're going to do f of -2 first. We're going to have -2 to the 5th power plus -2. The -2 to the 5th power is -32 plus -2 gives us -34. We're also going to do f of 2. So f of 2 is going to be 2 to the 5th power plus 2. The 2 to the 5th power is 32 plus 2 gives us 34. So if we see here, these two are opposites. So because they are opposites, we have an odd function. For example B, we have g of x is equal to 1 minus x to the 4th power. So we're going to do the same thing. We're going to plug in -2, we're going to plug in 2, so we're going to do g of -2 is 1 minus -2 to the 4th power. -2 to the 4th power is 16, I'm sorry. So it's 1 minus 16, which is -15. If we do g of +2, it's going to give us 1 minus 2 to the 4th power. So that's 1 minus 16, which is also -15. If we look here, these are the same. So when they are the same, we have an even function. For C, we have h of x is equal to 2x minus x squared. 2x minus x squared. So again, we're going to do -2, +2. So h of -2 is 2 times -2 minus -2 squared. The 2 times -2 is -4. And then the -2 squared is 4. So that's -4 minus 4, which gives us -8. For h of 2, we're going to have 2 times +2 minus 2 squared. So the 2 times 2 is 4, minus 2 squared is 4, 4 minus 4 is 0. So because these two are neither opposites nor the same, we have neither for this one. So if we get the same number, they are even. Opposite numbers, they are odd. And two totally different ones, they are neither.